Hi students, welcome to Math4U. In this session, I will be explaining some applications of Euclid's division lemma or algorithm. So I have taken some questions from your textbook to prove it. So show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1 where q is some integer. This is the first example. So what is given in the question? Let me explain to you the question. We have to prove that every positive even integer is of the form 2q and that of every positive odd integer is of the form 2q plus 1. And it is clearly given in the question q is some integer. Okay, I hope the question is clear for you. Now let me ask you, what is Euclid's division lemma? Yes, that is equal to A is equal to BQ plus R, where 0 less than or equal to R less than B. Okay, so here we are taking A as any positive integer. A is any positive integer. Okay, so can you tell me what is the value of B here? You can see here 2q plus 1. So B value is 2. So how this condition will be changing? Okay, so let us see 0 less than or equal to R less than. B is 2, right? So R can have values 0 or 1 because it should be less than 2. So now we are going to apply these values for R. So we have A is equal to BQ plus R, right? So A is equal to BQ plus R. So if first condition, if R is equal to 0, what will be the value of A? A is equal to, B is 2 we have, so 2q plus 0. That means A is equal to 2q. Now, second is if R is equal to 1, A is equal to 2q plus 1. So we got A is equal to 2q as well as A is equal to 2q plus 1. So what can we conclude? Yes, there can be any positive odd integer is of the form 2q plus 1 and a positive integer can either be even or odd. So we got A is equal to 2q and A is equal to 2q plus 1. We have proved. Is it clear? Yes. So let's move on to the next question. So the next question is show that any positive odd integer is of the form 4q plus 1 or 4q plus 3. Here also it is given q is some integer. Okay, so here we are going to take the Euclid's division lemma again. A is equal to BQ plus R where 0 less than or equal to R less than B. Okay, now here we are taking A as a positive odd integer. Or A is a positive odd integer. And what will be the value of B? Yes, very good. That is 4. Here 4q plus 1 is given, 4q plus 3 is given. Okay, so let us rewrite the condition now. 0 less than or equal to R less than, instead of B we can write it as 4. So what all values can have for R? R can have 0, 1, 2 or 3. It should be less than 4, right? So let us do the next. So I'm rewriting here A is equal to BQ plus R. Okay. So the 4 situations I'm going to do it. So first one is if R is equal to 0. So first condition, if R is equal to 0, what will be A? A is equal to, instead of B we are writing 4. 4q plus 0. That means A is equal to what? A is equal to 4q. Now the next one is if R is equal to 1. R is equal to 1, A is equal to 4q plus 1, right? If R is equal to 2, what will be the condition? What will be the situation? R is equal to 2, A is equal to 4q plus 2. And the last one, we have 3, right? So if R is equal to 3, we have A is equal to 4q plus 3. Now, you can see here 4q, A is equal to 4q, is equal to 4q plus 2. Are they odd or even? We can say that both of these are even because it is easily divisible by 2, right? So we have to take the other two, which is a is equal to 4q plus 1 or a is equal to 4q plus 3. See the question, this is what we have to prove also, right? So we have taken a as any positive odd integer and we got it as the form what 4q plus 1 as well as 4q plus 3. Is it clear all of you? So now we can see the last one, that is this question is from your textbook. Okay, I hope you can do it by yourself and check verify with what I have done it here. Okay, so I will explain. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5 where q is some integer. So here what we have to take? We have to take the Euclid's division lemma. A is equal to bq plus r where 0 less than or equal to r less than b. So what we have to take A as any positive odd integer, right? Positive odd integer. And what will be B? B will be 6, right? So how this condition will be changing? 0 less than or equal to r less than 6, right? Yeah. Now I am going to rewrite this equation as A is equal to, instead of B, I am going to write 6q plus r. So let us see which all values we can apply for r. So r can have values 0, 1, 2, 3, 4 or 5, right? So let us see. If r is equal to 0, a will be equal to 6q, right? 6q plus 0, that is equal to 6q. This is the first one. What about the second one? Second one is if r is equal to 1. What will be the value? A is equal to 6q plus 1, right? So the third is if r is equal to 2. A will be equal to 6q plus 2. Next is if r is equal to 3. What will be the value? A is equal to 6q plus 3. And the fourth one, let's see what is the value. 4. So if r is equal to 4, A will be equal to 6q plus 4. And the last one, we have the value as r 5, right? So A will be equal to 6q plus 5. So which all values we can take? Here, now you have to check the question. So we have to get the positive odd integer of the form 6q plus 1, 6q plus 3 and 6q plus 5. So same as the previous case, you can see here A is equal to 6q, A is equal to 6q plus 2 and A is equal to 6q plus 4, all are even. How can we recognize this? When we can divide this with 2. That means it is all these three are divisible by 2. So we got now as any positive odd integer will be of the form 6q plus 1, 6q plus 3 or 6q plus 5. So where q is any integer. I hope it is very clear. So I hope you will do it by yourself and check with this. Okay. Thank you.